Linux freaks in the room? This will appeal to you. Do you always turn SELinux off? Yeah, shouldn't. Also provide edge sheet dipping. And what edge sheet dipping is, has anyone done a Docker pull? Yeah? You do a Docker search, let's say Docker search wildfly, it comes back and says, oh, there's a container called wildfly, do you want to pull it? Docker pull wildfly. I call it Docker pull exploit my system, because you do not know what is in that container. There's nothing in the metadata that tells you where it came from. There's no history, there's no audit trail whatsoever. And the concept of sheep dipping is you take those images as they come into the edge of the system and you apply some scanning upon it to actually detect the defects, to detect the actual exploits, and you quarantine them then before they get onto your container runtime. So Red Hat CoreOS. Again, we acquired CoreOS, fantastic company. A little history lesson here. Anyone use RHEL? It's some kind of operating system, never heard of it. You know, get out. I'm a developer, so the underlying Linux doesn't really matter to me. But anyway, RHEL is a big bloated beast. It's an enterprise version of Linux. It has everything in it to actually run an enterprise version of Linux. And the problem with that is it has everything in it. So what we did around about 2.5 years ago was we took RHEL itself and we produced something called Atomic. Has anyone heard of Atomic or used Atomic? And the way we actually used it was we took RHEL itself and we shaved off all the bits you didn't need for containers. So we threw away the monitoring. We threw away Yum. We made it immutable. And we reduced it down to around 600 megs footprint, which was superb compared to the 7 gig footprint of a RHEL system. What CoreOS did was even better. And rather than taking a big fat Linux and shaving off the bits they didn't need, they started with nothing. So they said, right, what do we need to run containers? We'll put a kernel on there. We'll put systemd on there because everyone likes systemd. We'll put SSHD on there. So they put all the bits and pieces you need to actually run the container runtime and nothing else. And the footprint of container Linux, and to be honest, they chose Chromium or Chromos as the kernel. So it was a much smaller actual kernel than RHEL. But the footprint was trivial. So we decided to go the same way. So RHEL CoreOS is based on starting with nothing, putting the RHEL kernel in place, and then just putting the bits on top to run containers. It gets better than that. Does anyone know what a system container is? Shall I explain? Difference between system containers and normal containers. Containers are basically you take an immutable image from a registry, you install it as a file system because containers are file systems with delusions of grandeur. A system container is one step above. It's something that actually interacts with the system on the root level, and it's not actually contained as a normal container, but it's treated as a container. So the RHEL CoreOS out of the box doesn't have a container runtime on it. It is just basically the base operating system on which you can run containers. You can then download a system container for the kubelet, which is the little brain that does the things that Kubernetes needs, and the container runtime. And what we've done is we've produced Cryo. Anyone heard of Cryo? That's unusual. Cryo is a container runtime based on the container runtime interface provided by Kubernetes. So basically it's a container runtime that was designed explicitly to only satisfy Kubernetes pods. Now, put your hands up in the room if you use Docker again. What's the main problem with Docker? Apart from the fact that if your Docker thin pool gets full, your machine's screwed. Nope, try again.
Daemon process.
Yeah,
Try again.
Biggest issue for us is escaping our root.
Pretty much dead on. Every action you do in the Docker runtime, you do as root. So if you would do a Docker pull, if you would do a Docker search, anything that interacts with it, you have to go into the Docker process drops to root. And that is suicidally dangerous. The other thing is it's a big fat daemon. Everything you need to do with containers is inside of that Docker daemon itself, which makes it a big beast. So if you're buying, let's say, a node to run containers on, you want to run containers on it. You don't want to run Docker. Docker's a huge daemon. So what we did with Cryo was we split up all those operations. The building of containers, the running of containers, the extraction of containers from registries. And they're in separate applications, and some of them are not daemons. For example, if you run Docker run, which actually builds an image itself, it drops to root, it does all those kind of things. Amusingly, has anyone ever written a Docker build file in here? Have you noticed that if you put a comment in there, it puts an extra file layer into the image of 0 length? And me, I'm a developer, so I comment everything. So every image I produce is like double the length in terms of layers, and half of them are zero length themselves. Even Docker run drops to root. Now, builder will run as the process ID in which you run it. So if you have to do things like, let's say, yum or DNF or install those kind of things, you can adjust the actual process ID to actually cater with that. Anyway, I getting ahead of myself here. So CoreOS is an immutable operating system. Again, I was having a discussion a couple of days ago with a customer, and they were saying, well, if we use RHEL CoreOS or we use Atomic, we have to take on board another operating system. So our security guys were waiting for us to waiting for us to make a mistake. They're going to nail us for bringing a new operating system into the estate. And the way we countered that is that if you're running an immutable operating system, it can't do anything. So they were talking about putting specific things like sysdig or other kind of interpretation tools that will actually scan the runtime containers to look for exploits. Now, if you're running on an operating system that's immutable and only has the functionality to run containers, there's nothing to exploit. If you manage to break into the operating system, which is incredibly hard for the reasons I'm going to explain in a second, all you can do is kill containers. And if you're running Kubernetes or Openshift, you know it automatically recreates those containers. I wrote a specific container that was designed to destroy systems. That's what I used to do for a living. And this thing used to break in and just kill things randomly. It was like the ultimate chaos monkey. I ran it up on a Kubernetes system and didn't affect it. It redistributed those containers. The pods are redistributed. So that's all about reducing the attack vector itself. Now, anyone know Cloud Init? It's an old way of actually defining a system process. So when you actually set up on the machine itself, you run Cloud Init, it rebuilds the image to contain the actual system specific. If you're running, let's say, 500 nodes of Kubernetes or 500 nodes of Openshift, you have to have 500 images, because each image is separately configured by Cloud Init itself. When you run RHEL CoreOS, it uses a new technology called Ignition. And what Ignition allows you to do is define that system in terms of YAML. So you list basically a shopping list of how that system should be from a system perspective. And you have a singular image for RHEL CoreOS. When it runs the first time on the first boot, you can inject that YAML. And then that YAML is actually written into the memory of the actual image itself. And when it restarts, it fires up as the individual system. So in terms of actual system administration, you need one image. But anyway, that's something else. Tiny attack vector, nothing in the operating system apart from foundations for container execution. And the release cadence is tied into the OpenShift container platform, which is of interest to nobody because I'm not selling OpenShift at this point. Uncontained containers, the actual physical risks of it. And you can simulate this if you go and play with Docker on your systems right now today. If you're using containers out of the box, there are the following intrinsic risks. Number one, the container running as the host for root. Now, let's be honest about this. A container is a file system with delusions of grandeur. It thinks it's an operating system, but it operates within the process space that you give it. So if you're running Docker natively or running Kubernetes natively, these containers are running as root. And that's not just pretend root. That's root on the underlying host itself. So if you can imagine, a container can run up and it can remount file systems. It can create users, it can change group IDs, it can do all those kind of things. All the system capabilities, all the set comp profiles. And that's incredibly dangerous if you don't know what your container is doing. I don't know if people follow Docker, but around about 2 months ago, they had to take some of the Docker containers off of the Docker Hub. And the reason was they were Docker containers to do web servers. I think it was Tomcat or some kind of Apache HTTPD. And some customers were downloading it, absolutely fine, installing the file systems, serving pages, absolutely brilliant. Going home, drinking, all the usual kind of stuff. And then about midnight, the CPU would spike. And it was spiked for 4 hours. Because those images were doing cryptocurrency mining. And you didn't know that. When you're pulling Docker pull HTTPD or Docker pull Tomcat, there's no information that the Chinese intelligence service are using that container, but they were. And so Docker had to take those offline, but you don't know what is in a Docker image. And if you give that Docker image actually access to the underlying host itself, suicidal, absolutely suicidal. Containers running unconstrained in terms of system resources. Now I've got a personal experience of this because anyone use OpenShift? Oh, I wish there was more of you. Then we wouldn't have been bought by IBM. When I first installed Openshift 3, we didn't have the concept of actually controlling the system resources. So I set up a system that was 3 worker nodes and a control plane. And within 10 minutes of actually releasing it to my fellow solution architects, one of the nodes stopped working. And of course they phoned me up and said, you've broken it, fix it, all this kind of thing, because I'm dev and I don't understand ops. So I tried to SSH into it and I couldn't get into it at all. Couldn't actually physically SSH into the box. And after about 10 minutes of trying, I actually got onto the box. I did a top, no response. And after 10 minutes, I finally got a response to the top. And there was a Java process, bless, running at 540% of CPU. So that Java process, which was actually the Red Hat single sign-on, go Red Hat, was destroying the machine itself to the point that Openshift couldn't function. Because Openshift itself is pods that runs on the machines itself, runs on the nodes. So if you've got a container running unconstrained in terms of system resources, the noisy neighbor problem, it can destroy everything around it. You've also got the point of containers running unconstrained in terms of file systems. You know, when you run a container up, even though it's a file system with delusion of grandeur, you can map file systems from the actual underlying host. And when you do that, it has access to everything. It can go mad, run amok. Docker is security agnostic out of the box, and Docker is a singular daemon containing all container functionality, as I've ranted about in the last 10 minutes. Is root really a risk? Now, you know, I had to learn this because I've been at Red Hat for 7 years. When I was employed by Red Hat, I'd never used Linux in my life. I'm older than I look. I'm a VMS guy. Any VMS people? You all look too young for VMS. Thank you, Tim. But anyway, I didn't understand Linux, and I had to learn Linux as part of my job. Now, when you've got a root process running on Linux, which is user ID 0, it has a number of privileges above and beyond every other user. So you have a 0 process and you have non-zero process. And containers are file system processes with delusions of grandeur. If you give them root access, they're root. Doesn't matter if you're constraining them in terms of anything else. They are physically root on the host on which you're running. And containers are effectively slices of the operating system and operate within that structure. You've got to remember this. Containers are not black magic. They're not virtual machines. They're actually just file systems in the operating system. If you don't constrain them, they will have access to everything. And finally, a container running as UID 0 therefore has all the priv capabilities of root. And this is all the seccomp, this is all the sys capabilities and all those kind of things. I'm not going to read them out. Kernel 2.2 root capabilities, I like the last one. Cap sysadmin, all other hairy bits of seriously messing up an operating system. When you're running as root, you have access to all these system capabilities by default. That's what root is. It's the controller. Now, how Openshift, and this is Openshift, not Kubernetes, because Kubernetes doesn't do this. How Openshift defends against root is this. We've removed all capabilities from running containers. So when you run a physical container as a user on a worker node, as opposed to the way Kubernetes does it, we automatically force it into a user that's not root, and we force it into a group where we remove the system capabilities. Now, what's nice about it is that Openshift is a box of technical Lego, so you can configure anything to do this. And I was doing a job probably about 3 weeks ago with a small organisation called the British Army, which freaked me out because... Pardon?
Is that a startup?
Yeah, startup. Unfortunately, a startup where everyone seems to be walking around with a bloody handgun. Especially when they escort you to the bloody toilet. It's very, very off-putting. But anyway, I was dealing with these guys, and they gave us a task where they wanted to run 2 of their existing applications on Openshift. Well, piece of piss. You know, Openshift can orchestrate any Docker container. You know, we're Kubernetes, but we're Kubernetes locked down to the nth degree. And the bastards chose, number one, they chose a .NET application. Okay, which I was lucky enough because I was a Microsoft programmer for 3 years for my sins. Any Microsoft fans in the room? Yeah, so I was a Microsoft developer for 3 years, so I could solve that problem. But the other one is, anyone an Oracle fan? Good, because I can. Oh, you're recording it. Anyway, they want to run an Apex application in a container. Now, has anyone used Oracle Apex? Oracle Apex is just a standard Oracle application in that it wants to rule the world. You run it up and the first thing it does, it says, I must be root. And then it says, I want to change the group ID of the running process. And these are two things that we just neuter by default within Openshift. But the lucky thing about Openshift is we can actually expose some of the capabilities through something called security context constraints. So I managed to get around that, but you know, it was the worst two bloody things I could have actually done. Anyway, we actually define a non-zero PID within a root group. So when we run up the containers themselves, they get given a user ID that's non-zero, but they're actually assigned to the root group. But that root group is a neutered root. And what it does is we remove all system capabilities. So all those things I showed on the actual kernel 2.2 list, we remove from the actual process itself. We also make certain mount points within the container read-only. So it can't write to procsys, it can't write to sys, it can't write to proc/sysrig trigger. All those kind of things that influence the way in which the operating system under the covers runs, it can't physically write to it. And finally, OCP uses setcomp profiles to restrict system calls. And the reason I mentioned the British Army was you can actually trigger it using the security context constraints to actually allow containers to run with certain setcomps. So I actually set up the container to run with set group ID, and nothing else. I also allowed that container to run as root, but only root within that project namespace. So I alleviated the security potential within a single namespace. And I get lots of customers I talk to and say, well, in Kubernetes I can do this. It's like, fine. Install Kubernetes, brilliant. 15 minutes after you finish installing it, give me a ring. Because I'll give my eye teeth to bring your system down, and it'll take me less than 30 minutes to do it. There's no security. Kernel 3.8 namespace controls. Now, OCP uses PIC or PID namespaces and network namespaces to control containers. I'm going to show you a demo, assuming I have time, and I'm talking so I don't have time. We're about to release Openshift 4. It's a radical change, completely different in the way in which it installs, the way it works, and everybody is currently working to solve all the bugs with it. Now, I've got a running version of OCP 4, which is obviously going to fail, but I'll try and do a demo and show you basically what we do in terms of encapsulating these containers. So these allow Openshift itself to isolate processes activities within the container. The PID namespace hides all non-namespace processes from the running container. If you log on to a Linux system and do a ps-ef as root, you see every process. Every single process is running on that Linux system. Now what we do with the containers themselves, or what you should do if you're running Kubernetes and you actually use these kind of security approaches, is we lock the PID. So when that container runs, it only sees the actual processes that are of its own process ID. So it doesn't see the system processes, so you can't kill other people's containers, basically. And network namespace allows Openshift to impose network isolation on the container. I'll go on to that in a second, actually. We use something called Cgroups. Anyone heard of Cgroups? And what Cgroups allow you to do is they allow you to actually set up processes and constrain it to the resources it can use on the box. So you can stop this noisy neighbor issue. You can actually say this container can only run with X milli-CPUs, X amount of memory, and it's hard locked. It can't run beyond that, which is absolutely superb. And again, it limits can be strictly enforced on a container by container basis for CPU, memory, I/O, and network, and it negates any noisy neighbor issues. Right, everyone's favorite. For those who hate SELinux, this is going to be entertaining. For those who don't know SELinux, basically, when you install Linux or when you use Linux, it has two things. It has objects, it has processes. And what SELinux does out of the box is it actually locks everything down such that processes can't call objects. And it requires you to write rules to specifically say which process types can use which object types. And all kernel operations are then labeled, classified, and enforced using a defined set of rules. Nobody understands this slide. Nobody, even people that have been using SELinux for years, they don't understand it. What was lucky enough was a friend of mine in America made some cartoons. And I show this to customers a lot because it works a treat. Once you've seen these cartoons, you understand how SELinux actually works. So we've got process types. In this case, we've got two process types. We've got a process type called cat, and we've got a process type called dog. Okay? Object types, these are the actual parts of Linux themselves. We've got cat chow and we've got dog chow. When you install SELinux, nothing can interact with anything whatsoever. So what you have to do is you have to write rules as the administrator which allow processes to interact with named objects. So in this case, you would say the cat is allowed to interact with the cat chow, and the dog is allowed to interact with the dog chow. Now I'm going to show the next slide, and please feel free to laugh, because everyone laughs at this point for all the wrong reasons. That penguin is not molesting that dog. Okay, that's not the point. Okay, that penguin is the colonel who's stopping the dog from eating the cat chow. But every customer I show to it's like, isn't that penguin doing something naughty to the dog? No. So the rules will allow the cat process to eat food labeled with cat chow and the dog process to eat food labeled with dog chow. In an SELinux system, everything is denied by default. And this is very cool, superb. It stops the containers from interfering with the host. But what it doesn't do, it doesn't stop containers of the same type from interfering with containers of the same type. So if you're running two containers of type dog, they can both interact with the same dog chow. And that's bad. So what we've done, introduced something called multi-category security. And in technical terms, this is actually an extension to the labeling of the object types themselves. But now you can label the object types with a name itself. So what you can do now is you can have, for example, a process of type dog called Fido, and an object of type dog chow called Fido's food. And only Fido can interact with Fido's food. And what this provides us with is an absolutely rock solid way to stop containers interfering with each other. I hope that makes sense. I can show you a demo of it running and you'll see the SELinux constraints. This way with the cartoons is much easier. But we've introduced this, and this is enforced from the base up with Openshift. If you're running Kubernetes, you can do it yourself. You can actually enforce it, and I would highly advise you to do it because it stops containers of the same type interacting with the same objects. So Edgesheet dipping, changing subject slightly on this. So what we do with this is you've got to provide a point at which the images come into your system. You can't have your developers doing a Docker pull directly from key.io or quay.io. Is anyone know key? I wish you could turn this off. I work for an American company, doesn't understand irony, and they've demanded we call it quay. And I'd rather eat my own feet than call it quay because it's key. But anyway, there's a place called key.io, which is more of an open source approach to image registry than Docker Hub. The issue with this, if you're running an internal container runtime, if you're running Kubernetes inside, you're running Openshift inside, you do not want your individual developers to be pulling an image from the outside, especially with the situation of Docker not monitoring the actual images in which they do. So what we always suggest, if you're going to set up a container runtime or Kubernetes or Openshift on site, you have an Edgesheet dipper. And that's basically a standalone registry that sits in your DMZ. That's the place where all your images arrive. And the images, when they arrive in there on an event basis, are then scanned.